All right, so the problem says 6x cubed plus 7x minus 16 plus 10, and then it's being divided by something, okay? And in this case, it's going to be 2x plus 5. And again, remember, this is different than your packet. I'm just doing a problem very similar. So you take notes on this, but use this to help you answer those questions, okay? Now, just so that we're speaking the same language, when we divide something, the number or the part that's being divided is called the dividend. Okay, so that's the dividend. The part that you're dividing into that number or expression in this case, that is called the divisor. So the part you're dividing into it, that's the divisor. The dividend is the part that's being divided. So for instance, like if I took 6 divided by 2, 6 is being divided, so that's the dividend, and 2 is the divisor. And after I divide it, the answer, that's actually called the quotient. Okay? So the part that's being divided, dividend, the part that you're dividing by, the divisor, and the answer to that question is the quotient. Okay? So I'll be using those words just so that you guys know what I'm talking about.
Why don't you just say numerator and denominator?
Because numerator and denominator are literally, if all I'm doing is saying this is what this number is, I'm not like doing any type of operation, I'm not adding anything, I'm not subtracting, dividing, then I can describe the fraction. But when we're doing this operation of division, then we need to know what are we dividing, what's being divided. So it's a little bit different. Okay, so what we're going to use to divide is a box. Now you guys are used to using boxes the last couple of years, and actually even did in IM1 too, right? You're using the same box idea to be able to both factor, multiply, but now also divide. Now what we're doing with this problem is we're trying to check, is this divisor, is it a factor of that polynomial? So like you guys remember last week when you guys were doing this, and you were setting up, you're creating equations, right? Let's say that the graph was something like this, and it went through -3 and, let's say +2, and then you set up that equation. Those are factors. So what we're trying to do is figure out, is that a factor? And if it is, let's factor it out and then find the rest of the equation, okay? All right, so now when I set up this box, notice how I didn't like close the box, okay? Because I'll close the box when I finish setting it up. Your divisor goes on the left. So 2x plus 5, okay? Then I start making some columns. The first number, the first term, I'm going to put into the first box. So the first term always goes in the first box. What I do with the rest of the polynomial is I write that underneath. Okay, and I use this just for reference. I'm not actually doing, it's not a part of the answer. It's just, I use it for reference. Just makes it easier when I'm trying to figure out, the next steps. So the second term, I'm going to write underneath. And then this term here. And notice I put it right under that column, and then that term here. Now, if you remember, when you divide a number, let's say I divide 6 by 4. Well, does 4 go into 6 evenly? No, it doesn't. So the answer to that would be 1 with a remainder of 2. Now, you could reduce that. Yes, you could reduce it, and it ends up being 3/2. But if you guys remember, like in middle school, elementary school, you figured out how many times does that number go in there, and then what's the remainder, right? So we might end up with something like that, where you have a remainder. After that last number, this number that comes up in this box after I complete it, that will be the remainder. This last box right here will not be used, okay? Because once you find the remainder, that last box, you're not doing anything with it, so I just black it out. All right, so here's the steps. I put that first term here. I put the divisor on the outside. And then I put the rest of the dividend, or the number that's being divided, on the bottom, okay? Now, I'm filling in the box on the outside and the inside, just like you would if you were working with other boxes. I would say 2 times what gives me 6? 3. Then x times what gives me x cubed? What is it? X squared. Okay? And then I fill in the box below it. Then I say, okay, 3 times 5, 15. And then I also have to multiply x squared, because it's 3x squared times 5, so 15x squared. Okay? Now, the next step, when you go to the next column, is you start with that first box. So remember how we started with this one? We already had that number, right? That was the first term. Now to get to this term, okay, we have to use the numbers before. Okay, and this is how you do that. So I say to myself, all right, 15x squared, notice how these are the same exponent, by the way. They should be, okay? What do I have to do to get from 15 to 7? Do I add or do I subtract? And how much?
Subtract.
So how much do I subtract?
6? No, 8.
8. So to get from 15 to 7, I would have to subtract 8x squared. Okay? Now the steps are the same, just like you did in the first column. I say, okay, 2x times what gives me negative 8x squared. Okay, well, first, negative 4 times 2 gives me negative 8. X times x gives me x squared. And then I multiply down. So negative 4x times 5, negative 20x. And then again, I go down to this number below and I say, what do I got to do to get from negative 20 to negative 16? Well, first of all, I have to answer in my head, and is that increasing or is that decreasing? Am I adding or subtracting? When I go from negative 20 to negative 16.
You're adding.
I'm adding, right. Because remember, as the negatives get smaller, that means you're increasing, right? So I'm going to add 4x. So basically, and to double check, notice, negative 8 plus 15 is 7. 4 minus 20 is negative 16. And whatever I get here and here should add up to 10. Okay, so now 2x times 2 gives me positive 4x. All right, then I multiply again. 2 times 5 is 10. Last step, what number do I have to add to get to 10? I don't have to add anything. So my remainder is 0. So if you don't have a remainder, you should end up with 0 right there. Now, when you write your answer, all we're looking for is the quotient. So that is your quotient for the answer to the division problem. 3x squared minus 4x plus 2. Now, just so you guys know, if you watched the proposal already or you're about to, this is slightly set up slightly different than what Ms. Menard did. I just don't have like this extra row and column out here with like 1, 2, 3 and A, B, C, but it is the same thing.
There has to be another way to do this. Isn't there like a PQ method or something like that?
You're thinking of synthetic division, which is tomorrow. Okay, there is another method. Okay. All right, so this is called long division or box division. And so we'll look at the other type of division tomorrow. Okay. All right. So again, that is what we're looking for. That quotient or that your answer comes on the top. So if I have a remainder of 0, what that means is that 2x plus 5 is a factor of that polynomial. Okay, the other way I could write this is to say, all right, well, that means that 2x plus 5, if I multiply it times that, it should give me that same polynomial, okay? And then what I could do is factor that part a little bit further and now find the rest of the factors, but we're not doing that here. We're just dividing that first part. Okay. All right, so now on the next one, you guys might recognize this. Okay, these are all division problems. They're all just written a little bit differently. Okay, so here I've got 3x plus 1, 6x cubed, plus 11x squared, minus 12x, and minus 1. Okay. Setup still the same. Set up my box. Okay, 3x plus 1, dividend goes to the left. Sorry, divisor, not dividend. 3x and plus 1. Then I'm still going to write that first term. This one right here goes in that first box. Okay. Then the rest of the terms go below. Again, I'm just writing it in a different color just because so I know I'm not using, this is kind of a separate part of the box, okay, to distinguish it, but I'm looking for those numbers up here. That's ultimately what I'm trying to get to. All right, so I put it right underneath, right? And so that since that's my last term, then I could close the box over here, one more column, block that out, and write the remainder here. All right, so now I just got to work through the steps. Okay, so again, start up here, start in the top left, and say 3 times what is 6? Well, that'd be 2. X times what is x cubed? X squared. Okay, then multiply 2x squared times 1. Now that's nice. This is just 1, right? So now I know all of these will be the same as the number at the top because I'm just multiplying 1. So that'd be 2x squared here. Then I have to look at these two numbers and say, what do I have to add or subtract to get to positive 11 squared? Well, that'd be 9x squared. So 9x squared plus 2x squared gives me 11x squared. Because remember, these two have to add up to get to that one, or that second term. Then I follow the steps as before. 3 times what is 9? 3. X times what is x squared? X. And then 3x times 1 goes there. Okay. Then I'm going to go from 3 to minus 12. Well, what do I have to do to get from 3? And remember, we're going down to negative 12. So we're subtracting. So how much do I got to subtract?
Was that 9? Wait, no. 15?
15. Yeah, 15. Okay, so I got to subtract 15. So just to think about that, I'm going from 3 down to negative 12. At some point, I get to 0, right? So I go down 3, and I got to go 12 more, so that's 15. So I'm going down or subtracting 15. Okay, so now 3 times minus 5 is 3. And it's already x, so 3x times negative 5 is 15x. So I don't need the x. Now negative 5 times 1 minus 5. And now notice how these numbers don't match. In the last one, those did match. I added 0. So because they don't match, that means I'm going to have a remainder. So same thing. If I'm going from negative 5 up to negative 1, I'm going to be adding 4. So 4 is my remainder. Okay? So now when I write my answer out, I'm going to write it like this. I'm going to use the quotient, the part on the top, and write 2x squared plus 3x minus 5. And now I have to add the remainder to that expression. So when I do that, it's plus 4. I'm going to do plus 4 over what you divided by, your divisor. 3x plus 1. So that's that kind of key part here is if you have a remainder, you put that number over what you divided by. Okay? So put it over what you divided by. If you don't have a remainder, then you don't have to write anything. Or sorry, like this. You don't have to write anything after. Okay? Also, if you have a remainder, that means that that is not a factor of that polynomial. It does not divide it evenly. It is not an x-intercept of that. Okay? Okay. Go over here. Okay, now, again, this was a lot like part C, by the way. This one is going to be a lot like part D. Okay, so this one, I have x to the 4th, make sure I'm not in the way, plus x minus 1 divided by x minus 2. Okay? So give you guys a second to get caught up if you're copying this down. All right, so now this one. Okay, what's important, if you guys notice in the last problems, is that if you look at the polynomial that's being divided, the dividend, the exponents are all there. Like they go in order. They go from 3 to 2 to 1 to 0. And then the one that was over there, this one, it goes 3, 2, 1, and then nothing, right? So when we get to this one over here, what you guys have noticed, it starts with 4, and then it skips on over to just 1. So you have to account for those missing terms, okay? So I'm going to rewrite this first before I set up my division problem. So first I got to write x 4th plus, what I do is I write 0x cubed. So the next one should be cubed. So anything that's missing, I just write it as a 0 term. So plus 0x squared. Now I have the next one. I do have an x. So I put plus x minus 1 over x minus 2. Okay, and what I'll do is I'm going to change this color just to kind of emphasize it. Don't drop my box. Not changing anything, just using color, okay? Just to emphasize those missing terms, I got to write those in, okay? Now, once I have those, now I can set up the box, okay? So set up my box. Okay, put the divisor on the outside. Start with the first term in the first box. And then the rest of the terms, right, I write underneath. So this one, this one, this one, this one. So I got 4. So plus 0x cubed. Oh, sorry, my bad. It should be to the fourth, not the third. Okay. And then plus 0x squared plus x, and then one more for minus 1. Okay, so here I need to column over the -1, but I also need one more for the remainder, if there is one. So I got to put one more column there, R. Okay. Okay, so now I've got it all set up and ready to go. So now I start with the top left. X times x cubed is x to the fourth. X cubed times -2 is -2x cubed. And then again, -2 plus what gives me 0? It'll be positive 2x cubed. Okay, so 2 minus 2 equals 0. It should work. When you look at it diagonally like that, these numbers should add up to that number. 4 minus 5 is 1. 15, -15 plus 3 is -12. 9 plus 2 is 11. Okay. Now, what do I have to multiply to get this number on the top? X times 2x squared. Okay, because all I'm doing is multiplying an x. Then 2 times -2, -4, times x squared. Okay. Same thing, -4 plus what gives me 0? Positive 4, x squared. Okay, then what do I have to multiply? Times x to get 4x squared. Just be 4x. Then 4x times -2 gives me -8x squared. I'm sorry, not squared, just 8x. Then what do I have to add to get to 1? -8 to 1. -8 all the way up to 1. Remember, there's a 0 in between here, right? So I'm going up 8 to 0, then another 1, which means I'm adding 9. Okay.
The exponents, when you're writing in the boxes, they should be going down too, right? So then you know you're doing something right.
Yep. So there should be 3, 2, 1, and nothing. Yeah, you should see that same flow the whole time through. Okay, so that, yeah, you would be making a mistake somewhere if you didn't see that. So x times 9. Okay, the question was, somebody asked, should I see the same order of exponents as I go through? Yes. There should be like a flow, a pattern through your box. I should see the same terms here, going diagonally. And also, I should see 4, 3, 2, 1, or here 3, 2, 1, nothing. So I should see that same pattern all the way through. All right, last step, 9 times -2 is -18. And then what do I have to add to 18 to get to -1? Positive 17. Now, obviously, I have a remainder, so I got to write this out with a remainder. X cubed, starting, remember, with the numbers on the top, plus 2x squared, plus 4x, plus 9. And then I take the remainder. In this case, it's positive, so I'm adding it. And then I put it over the divisor, x minus 2. Over x minus 2, okay? And that ends up being your quotient, or your answer, which has a remainder in this case, okay?
How do you know how many boxes to do? Do you count the number of exponents? Or
So-
like the greatest, I guess.
So you start with that first term when you set it up. So the question is, how do I know how many boxes to set up? Okay, well, I start with the first term, I put it in there, and then the remaining amount of terms determines how many boxes you have after that. So I start with that first, then I put the second, the third, the fourth, and the fifth term in this case, and I always need one more box after that to write in that remainder. So basically, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Up here, 1, 2, 3, 4, 1, 2, 3, 4. So yeah, I guess you could go that way. Is just say that the amount of terms tells you how long your box should be. Okay. Okay, we'll do one more example. Again, this is from the one on the bottom. The very last one down there. So again, make sure, guys, that you write in, I'll put this back up there, but you want to write in x cubed plus 2x squared minus 7x minus 2, and the x-intercept is 2, 0. Okay.
You posted that, right?
I will post it. Okay. I didn't post it online, but I will post it. I just talked about it in the last 2 classes. Okay, so I'm going to use this space to do that one. Okay, so remember again, the one I'm showing you is different from what you've got. It says, given the puzzle below, what are all the x-intercepts? So here's the goal. It's going to give you a function. It's asking you to find all the x-intercepts. Okay, and you already have one of them. So here's the function. By the way, this is for 8-90, just 8-90. Okay, so here's a function. 8x cubed plus 8x squared plus 18x plus 9. The question already gives you one x-intercept. One x-intercept is -3, 0. All right. What it wants you to find is find all x-intercepts. Now, before I start solving this, let's know where we need to end. All right. I already have one. And if you guys remember from yesterday, I can determine how many total x-intercepts I have by looking at the degree. What is the degree here of that polynomial? 3. So that number up there, that tells me the degree. So that means that I've got 3 of them, 3 x-intercepts. Which means how many more do I have to find? I got to find 2 more. All right, so here's how we're going to do this.
Can't you just factor it?
Okay. Let's see. Did I factor that? Like factoring by grouping wouldn't work. So you'd have to do this other method called like you were talking about, the PQ method, which is a rational root theorem, which is kind of not my favorite. Yeah.
I hate that method so much.
So this division is kind of the best way to go. Okay. All right. So somebody asked, can't we just factor it? And remember that when you have 4 terms, you would have to do factoring by grouping, but factoring by grouping doesn't work for every problem. So in this case, it wouldn't work. You'd have to do division. Okay. So first, I'm going to turn the x-intercept into a factor. If it's -3, that means that my factor is x plus 3. Okay, so I need that because that's what I'm going to use to divide. That's now my divisor. All right, so now I'm going to set up my division problem. Basically, guys, what I'm going to do is take that dividend and divide it by that. So we're going to divide these 2. All right. All right, so now I'm going to put this on the side. Move this out of the way. I'll fall in it. Okay, so I got x, 3, first term, which is that one. And then I'm going to write in the last terms, which are 3. So remember, I got 4 terms, so 4 boxes. So let's just go ahead and complete our box there. So I'm gonna write the last terms here. So 8x squared, then plus 18x, and then plus 9. And as you know, the last one would be your remainder. Okay. Okay, so now x times x squared, then multiply 3 times x squared, 3x squared. Then 3 plus what will get me 8x squared. It's just 5. Then multiply again. X times what gives me 5x squared? 5x. Then multiply 5x times 3, 15x. Again, notice I'm adding these two, right, to get that one. So what do I have to add here to 15 to get to 18? 3x, okay? X times 3 is 3x. And then 3 times 9, or 3 times 3 is 9, which means I have a remainder of 0 because those numbers are the same. Okay? So I'm not going to write it out like that, like a quotient, because I'm using division to factor. I'm using it to factor. So here's the new function now. F of x equals that factor, x plus 3, okay, times the quotient, what I came up with, x squared plus 5x plus 3, okay? So basically, I just factored that quotient, and now it looks like that, okay? Now what I've got to do is, remember we said there's 2 more x-intercepts, right? That doesn't tell me what the intercept is. I'm going to use that to find them. So that means I'm going to have to try to factor that. So I can try the x. You guys might notice already, if I put 3x squared up here and 5x, there aren't 2 numbers that are going to multiply to 3 and add up to 5. So you guys probably already know what I'm going to have to do. Quadratic formula. Okay? All right. So I'm going to set that up. So here, because again, all we're looking is for the x-intercepts. I don't need to actually write out all the factors like the equation. I just need the x-intercepts, which I already have 1. So now -5 plus and minus 5 squared. So I'm just going to write 25 minus, actually, let me write 5 squared just so I don't confuse anybody. 5 squared minus 4, remember it's always part of the equation, times a, which is 1, times c, which is 3, divided by 2 times a, which is 1, and now simplify. Okay, now, you guys could, if you want, you could just plug that into Desmos, and you'll be done. And you get 2 answers, right? You do plus and minus. I'm just going to do 1 step, and then I'll use a calculator. Okay, so -5 plus and minus. So this is 25. 4 times 1 times 3, that's 12. So I'm doing minus 12, which gives me 13. And then 2 times 1 is 2. So now what I'm going to do is use a calculator to divide the rest, or figure out the rest. I'm just going to use a handheld calculator. Again, Desmos is probably your easiest bet here. -5 plus the square root of 13. I don't know if you guys can see it. Okay, then I had equals. All right, then I have to divide by 2. All right, and I get -0.69. So I'm just average it that, or round it to the nearest 10th, so 0.7. Which means x equals -0.7. And then remember, I just got to do the same thing. I'm just going to go back up and do minus. So do minus and then divide by 2. So now I get negative 4.3. Remember, there's one more, right? We already had it. It's right there, negative 3. So there's all the x-intercepts, all the roots, all the solutions that we were looking for, okay? Okay, I'll pause it for a second.